Okay, guys, I'm going to give this a try. This is section 7.2, part 2. This is what we did Friday in class, but we didn't get to the last problem. So I thought that would be a good practice for me as well. So we'll just do one problem here. These are the directions that we've been doing. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. So that's what we've been doing. Remember, this new piece is that specified line is going to change. So let's look at one more from Friday. Let's take a look at, let's see, hopefully this paper will work. We're going to take a look at y equals x and y equals the square root of x. And we're going to go about, let me bring it down just a little, about y equals 3. So that's our new part, y equals 3. Okay, so let's do a picture. Go to your calculator. That's not a big deal at all. Y equals x cuts it like this, and the square root of x, at least for a portion, I'm going to kind of over exaggerate it, but at least for a portion goes like this. Okay, it's not very big there, but you should at least see on the calculator that the square root goes above it. So the new part is now we're doing y equals 3. So we might want to take a look like where that is. I think this is a little bit above with the calculator. That might help as well. If we have to ever come back and adjust that, we can. All right, so this point is like up here. Okay, and this point would be kind of like up here. We got our line going this way, and then we've got the square root piece kind of going that way. Okay, so and let's actually, maybe we should find those pieces. Let's also draw in our circle. We'll just do one right here randomly. And here's our other piece. Notice that it is a washer, but notice that this time our washer is this way. So that means we want everything, so we're going to do outer minus inner, and we're going to do it in terms of dx. That's probably pretty important. You've got to identify that we're going, the thickness would be left to right. Anytime the thickness is left to right, that is dx. So everything has to be in terms of x. So let's go ahead and find this and this in terms of x. So we'll set those two equal to each other. We'll do x equals the square root of x. Okay. Square both sides. So we get x squared equals x. Move it to the other side. X squared minus x equals 0. We could factor out an x. We're left with x minus 1. And we have x equals 0 and x equals 1. Okay, so that means we're going here at 0, and here we're stopping at 1. Again, we're going x values, which is perfect. Everything's in terms of x. Okay, so that means we can actually add this, 0 and 1. We're in good shape. Okay, so now we need to do 0 to 1. We need pi r squared minus pi r squared. Okay. So let's take a look now. Here's the part with this line not being the x or y axis. This is going to give us the outer. Okay, let's take a look. The outer is the line. The outer is the line. But this equation goes here. That's the problem. Our equation goes here, and we need this. So in order to get that missing piece, you have to do, let's go from 0 to 1 pi, you have to do 3 and then minus this distance. That distance was the line, so minus x. Okay, and then pi. Okay, let's try it again for that inner circle. The inner circle is going to take us to here. But we need this distance. We need the exact opposite. So we need to do 3 minus the square root of x. Because the square root of x is up to here, but we need the reverse. We need the other piece. So we need to do 3 minus that square root of x, and that'll give us what's left over. Okay. So just like the line, 3, take away what we have this, and then that'll actually give us what's left over. Okay, let's sneak in a dx. And I think we're good. Now it turns into algebra, so that's the new part. When you have to do, you're on actually the other side. You're always on the side from the axis. That's just the way it works, right? These equations are based off the origin, which touches the axis. So this information is always from the x-axis, and we needed the other piece. All right, so this we can factor a pi out. Let's slide it up a little bit. So let's bring this down. We'll take the pi out. We'll factor out a pi. Okay, we're going from 0 to 1. We'll do 3 minus x. We'll write that out twice. And then minus 3 minus the square root of x. We'll write that out twice. Okay. All right, FOIL. 9 minus outer and inner together is 6x plus x squared. Just be careful here of the minus. 9. And then outer and inner here gives us negative 6 square root of x. And then last gives us plus x, right? Square root of x times square root of x is x. Good. All right. So can we still see? Okay. Let's collect like terms. Or let's distribute the negative. Negative 9 plus 6 square root of x. And then minus x. Okay. So those two drop out. That's good. We got an x squared. We've got a minus 7x. We'll collect like terms. And then this guy's by himself, so we'll write it as 6x to the 1/2. Okay. What else? So this is where I would do this guy, just make sure we don't lose him. We haven't taken the integral yet, so we will still go from 0 to 1. All right, so let's finish it. Let's see, where can I put this? Still learning this, guys. All right, so pi, let me just rewrite it from 0 to 1, x squared minus 7x plus 6x to the 1/2 dx. Okay. Okay, so now we're ready. Now we can take the integral, right? Okay, this is where just don't lose that guy. Add 1, divide by the new. So that gives us 1/3. Add 1, divide by the new. 2. Right? Okay, now just be careful here. Add 1 takes us to 3/2. Divide by 3/2. Picture dividing by 3/2. That's the same as multiplying by 2/3. Okay, and then we've actually taken the integral, so we can do from 0 to 1. Good. The only thing is maybe let's clean this up just a little bit. 1/3 x to the 3rd minus 7/2 x squared, and that would give us what? That actually gives us 4. 12 divided by 3, 3/2, 0 to 1. Kind of not too bad, but remember we're just plugging in 0 and 1, so that's really nice. So we'll plug in a 1. We got 1/3 minus technically 1 to the 3rd minus technically 1 squared, but that'll just give us 7/2, and then plus 4. And then the 0 is even easier, right? When we plug in a 0, the whole thing goes away. 0, and then a 0 in there. Okay. Good. So it's just this guy. Type that into the calculator. We could get a common denominator, but this is 5/6. And then just don't forget your pi. So 5 pi over 6. That is the volume of this little washer getting spun around. Or not, I'm sorry, that's the volume of what? This whole thing, right? This was just one little washer, but this whole thing from here to here getting spun around. Okay, and subtracting out that middle, that volume is 5 pi over 6. Okay, so now if you haven't, if that helps at all, hopefully you can now finish section, I'll put it right here, section 7.2, part 2 on web assign. Thanks, guys.